Hello grade 8s, and welcome to our second lesson on functions. In this lesson we're going to learn to go with the flow and use a flow diagram or other tool to figure out the outputs of function rules. What I want to introduce you to now is a flow diagram. And in this flow diagram, things move from going into a system, they follow a rule, to going out of a system. So things are going to go in, they'll be changed by the rule, and they're going to come out. It's very similar to what would happen in a factory when you take raw materials like aluminium and silicon and put them into the factory, and out would come a phone. We've already seen something like this in our previous chapter, where we were looking at number patterns. In that particular unit, we put n in, a number for n, we used a pattern rule, and a tn, or term 3, or whatever, would come out. Now we've moved on, and we're using different notation of x's and f of x's, but the same idea applies. The 2 is going to go in here for x. The relationship is multiplication, so we'll say 2 times the 2. We'll add 1, and we'll put the output on the right side. So I'm going to write over here on the right side, just so we see what's happening. You don't have to do this unless the problem is very complicated. But if I go through the entire function from in to out, I'm going to put 2 in for x. I'll get 2 times 2 plus 1, and my output is going to be the number 5. If I go to the next one, I'm now going to put 1 in for x, and I'll get 2 times the 1, which is going to go in for x, plus 1. All right, so 2 times the 1 is going in here, plus 1. That's going to give us a total of 3. And then the easiest one, which we can do on our heads, 2 times 0, which will be 0 plus 1, will give us an output of 1. So that is a function flow diagram. It can determine outputs. Later we'll be able to determine inputs and rules, but the idea is that something goes in on one side, for example, the input, the rule changes it and produces an output. We'll now move on to a second type of problem where we need to use a different type of notation called set notation to complete a table of inputs and outputs for a particular function rule. Looking at set notation, it can seem very complicated, but all it really means is that the x values must be these values here, -2, 0, 1, or 2. Those are the inputs that are supposed to be used to produce outputs from the function rule. If we read it in fancy mathematical English, we would say that x must be an element or part or a piece of this particular set of numbers, and these fancy brackets hold the numbers in. So x must be -2, 0, 1, or 2. So with that information, we can now start creating our table. And we only need to put 4 values into our table. You should always, if you can, try to put your numbers from smallest to biggest or biggest to smallest, whatever order, but make sure the numbers are in order. Again, the link between this, x, the values of x must be these values in the set notation. So now we're ready to create outputs. We must use these inputs for x to create outputs here. And to do that, we're going to need to use the function rule. So the function rule tells us that f of x is equal to x plus 2. So what we have to do to get the first value is insert the -2 for the value of x, and we insert it where x used to be. As we do this and calculate this, we're going to figure out and determine that the value of the f of -2 is going to be 0. And we're going to input that number into the output section of our table. Now take a moment and see if you can determine the remaining values in the table. All right, here we go. If you put in 0, 1, and 2 for x, using the rule of x plus 2, 0 plus 2 equals 2. And we put that up there in the table for when x is 0. The output is 2. Then if we do the rest, the remainder of it, when we put in 1, we get 3. And if we put in 2, we get 4. And that's all there is to it, grade 8s. It's very simple to determine function outputs. Always just be careful that you don't make any errors with negative numbers, and you check your work on your calculator. Good luck!